What's going on, guys? Let's look at this problem right here. Here this question is asking a silicon sample is doped with 10 to the power of 17 boron atoms per centimeter cube. What is the electron concentration NO at 300 Kelvin? Here they are asking for the N0 value, that is basically equilibrium concentration, and here they are also mentioning this is like boron atoms, doped with the boron atoms. So when we dope with the boron atoms, we are dealing with a p-type semiconductor. So the electron concentration is going to be like minority carriers, okay? And we know that if we have we have to find out p0 first in order to do this problem. p0 is basically acceptor concentration. We can also write this one as Na. So acceptor concentration, that is given 10 to the power of 17 boron atoms. This is acceptor concentration because boron means this is a trivalent impurities, so this is going to be acceptor concentration. So we are going to have 10 to the power of 17 per centimeter cube. Here the question is asking for NO value. NO can be calculated using this formula, Ni square divided by Na, right? Acceptor concentration, and in the numerator we have Ni value. Here we have Ni value for germanium and silicon, two different values, but here we are dealing with silicon, right? So we have to use this one, 1.5 times 10 to the power of 10 per centimeter cube. So we are going to use that one. Since we have centimeter for both, we can keep the unit as it is. So this is going to be what, 1.5 times 10 to the power of 10 square divided by 10 to the power of 17, and this is going to give us 2.25 times 10 to the power of 20 divided by 10 to the power of 17. Finally we will end up with 2.25 times 10 to the power of 3 per centimeter cube. Now you can compare the electron concentration compared to the boron concentration. This is very small, right? So that's why we call electrons are minority carriers in the p-type semiconductors. And that's how we do this kind of problems. I hope this helps. Thanks for watching.